UTME Physics practice problems. I'm currently on question number 11. So if you want to see the video for other questions, just check the previous videos. Now question number 11 says that a runner completes one full lap of a 400-meter over track in 50 seconds. What is the average velocity of this runner? So let's say this is the over track and the run, everything is 400 meters, but the runner completed everything in 50 seconds, and we're asked to find the average velocity. Now, there's a difference between average velocity and average speed. Average velocity, average velocity is total displacement divided by the total time taken, while average speed is total distance covered over total time taken. And what is displacement? Displacement is simply the length of the distance between the starting point and the end point. In this situation, if it is completing one full lap, that implies that if it starts from this point, so it goes around the over track and made it back to this place. So the starting point and the end point, they are the same thing. And the length of that will be 0. So that implies that in this case, the average velocity is going to be 0 meters per second, because this is velocity and not speed. The second question says that a planet in a science fiction film has twice the radius of the Earth and half of the Earth's mass. Gravity on the planet would be about, so it's obvious that we are looking for this answer in terms of g, that is acceleration due to gravity on Earth. Now, we need to know that acceleration due to gravity on any planet is simply the product of g, gravitational constant, multiplied by mass of that planet, then divided by the square of the radius of that planet. So in this situation, we know that g on Earth, which is the actual g, that this is approximately 9.8 meters per second squared. Now g is g, then mass on Earth, then radius of Earth raised to power 2. So for this particular planet, now we've been given some information. So this will be g. Mass of the planet is half the mass of Earth. So here we'll have 1 over 2 multiplied by me, and then the radius is twice that of Earth. So as twice the radius of the Earth. So divided by, that will be 2re, everything raised to power 2. So when we simplify this, so this is not part of it. When we simplify this, we're going to have 1 over 2, then this one will be squared, multiplied by 4, then g will be left there. We have me divided by re squared. So if you do this very well, that would be 1 over 8 multiplied by gme over r squared is g. And 1 over 8 is 0.125. 1 divided by 8 is 0.125. So the correct answer to that is 0.125 g. So this will be the correct answer. The next question says that a swimmer swims with a velocity of 2 meters per second relative to the water. The river flows at a 1 meters per second downstream. What is the magnitude of the swimmer velocity upstream? Now, the swimmer can swim 2 meters per second relative to water. Now, in this situation, so permit me to just delete this ones. I believe you can check the video or take a screenshot. Now, so the swimmer can swim at the rate of 2 meters per second. Then the river flows 1 meters per second downstream, so 1 meter per second downstream. So what is the magnitude of the swimmer's velocity upstream? So if the swimmer is swimming upstream 2 meters per second and the river is flowing 1 meters per second downstream, so this is a vector in opposite direction. So if you want to find the magnitude, the net resultant velocity in this place, that will be 2 minus 1, which will be 1 meter per second upstream, because upstream has the higher velocity in this case. So therefore, the swimmer will still be able to make it upstream, but with a slower velocity of 1 meters per second. So the magnitude is what we need there, and that will be 1 meter per second. Okay, to the next one, we have the resultant of two vectors is minimum when the angle between them is. Now, we have these different cases. First, we have this first case. We have a second case. This is perpendicular. We also have another case where two vectors can be at any angle, and we have a case where the two vectors can act in the same direction. Now, this angle here is 180 degrees. This one is 90 degrees. This one is just any random angle theta, and this one is at angle 0 degrees. Now, among all of these guys, the guy with the maximum impact will be the guy at 0 degrees. The guy with the minimum impact will be at 180 degrees. Now, every other guy from 90 degrees, theta, or any other random angle between 0 degrees and 180 degrees, they will have their values fall between what the minimum is, that is at 180, and what the maximum is, that is at 0 degrees. So the minimum happens at 180 degrees, while the maximum happens at 0 degrees. So that is how you tell that. So take note of that. The next one, number 15. Number 15 says that an elevator has a mass of 500 kilogram. It may safely carry an additional mass of 1000 kilogram and accelerate upward at 2 meters per second squared. What is the tension in the cable under these maximum conditions? So I'm going to delete this again. Now, let's quickly draw what an elevator looks like. So let's say this is the elevator connected with a cable. This is where and then the mass is placed inside. Let's say this is the mass. Now, the way it happens is that the weight of the entire elevator will be acting downward. So weight is acting downward. And as the weight is acting downward, tension will be acting upward in the string as well. So these are the two major forces that are here. And from what we know here, let's calculate the total weight that will be acting downward. The elevator itself has a mass of 500 kilogram. And then the maximum mass that it can carry is 1000. So that means that we have a total mass of 1500 kilogram. And if you have to convert that to weight equals mg. So altogether, we multiply this by 10, which is the acceleration due to gravity. And that implies that the weight that is acting downward will be 15,000 newtons. So we've gotten the weight that is acting downward now. So it says that if it accelerates upward at 2 meters per second squared, whenever you have elevator like this, what you want to do is that you want to analyze where is the motion of the elevator going. Is it going upward or is it going downward? Now, if it is going upward, that implies that your net force is going to be tension minus weight, which will be equal to mass times acceleration. This is if it is going upward. But if it is going downward, it will be weight, because weight is the force acting downward there. So weight minus tension will be equal to ma. This is if it is going downward. So I'm going to be using this first one in this case. So using the first one, that implies that tension minus the weight is 15,000, and the mass itself, total mass, is 1,500. The acceleration, we were told that it's accelerating at the rate of 2 meters per second squared. So that's 2. So that implies that the tension will be 1,500 times 2. That is 3,000. Then negative 15,000 will go here. So it becomes plus, and we'll have what? 18,000 newtons. So the tension in the string will be 18,000 newtons. And that is how you solve that kind of problem. I'm going to be stopping at question number 15 for today. I'm going to continue with question number 16 and other questions in the next video. Make sure you subscribe, like, comment, and I'll see you in the next one.